Hello, today we will cover exercise 9.3 of 9.3 and question number 6 of Ncert book chapter 9 it is on circle. So question 6 how it is ABC is a cyclic quadrilateral whose diagonals intersect at point E. ABCD is a cyclic quadrilateral. It is given cyclic means the quadrilateral whose all the 4 points are on a circle. You see 4 points are on a circle. And diagonals intersect at the AC is a diagonal, BD is a diagonal, and this is intersecting at point E. Okay. And what is given? Angle DBC equal to 70 degree. Angle DBC 70 degree. Angle BAC 30 degree. And line AB equal to BC. And you have to find the angle BCD and angle ECD. This you have to find out. Now we will solve the question. Okay. So here angle DBC equal to angle D, B and C means this angle is 70 degree. Angle BAC is 30 degree. Angle BAC means this angle, this portion is 30 degree. And AB line is equal to this line. Okay. Now here we are going to do. You see this is a chord. DC is a chord and of this chord, one side is of the circle is this one and another is this side. Okay. So if any angles in the same side, here it is the center. So angles in the same side, so this angle A and angle B is made by the chord DC. So this angle and this angle will be equal. That's why angle DAC will be 70 degrees. This we are writing. Angle DBC 70 degree and angle DAC will be 70 degree. Why 70 degree? Because angles in same segment made by the chord DC will be equal. Okay. Now you see the whole angle is now 100. BAD is 100 and BCD. These are the quadrilaterals to opposite angles and their sum should be 180 degree. So if 100 you reduce, so 80 will remain here. So BCD will be how much? BCD will be 100 minus 180. 180 minus 100 equal to 80 degree. This full angle will be of 80 degree. How it comes? Angle BAD is 30 plus BCD equal to 180 degree. It should come. BAD, this full angle 100. So sum of opposite angles of cyclic quadrilateral are always 180 degree. So if one is 100, so angle BCD will be 180 minus 100 equal to 80 degree. So it is your one answer. Now we are coming to our next question, part 2. So here what happens, you see this line and this line are equal. So if you take a triangle, ABC, if you take the triangle, here AB line is BC, AB line is BC line. So it is isosceles, means two lines are equal. Then what happens? The equal lines have equal angles. So opposite to it. So here, if for this line, BC line angle 30 degree angle is there, then AB line also opposite angle 30 degree, here it will come. So angle A and angle C here 30 it should come. So what happens? Angle BAC will be equal to angle BCA. BAC will be equal to BCA. Okay, and that too will be 30 degree. Now the whole angle here, it is 80 degree angle. Now angle BCD will be equal to BCA plus ACD plus ACD or ECD. We can write because ECD they are asking, that's why we have taken E. Otherwise we could have taken A CD name is the same. So ECD. Okay. So 80 BCA is 30 degree. We have proved BCA is 30 degree. BCA is 30 degree. And BCD we have already proved 80. So 80 minus 30. So angle ECD, how much it will remain? 50 degree it will remain. So your answer is angle BCD. Angle ECD means this side. This side of the angle it will be 30 degree. Means this 30, so it will be also 30 equilateral, and it is 100, so it will be 180 minus 100. So how much it should come? It should come 80, so it is coming 50 degree. 50 plus 30, 80, and 100, 180 degree. Opposite angles will be equal to 180 degree. So in this way, question 6 is over. Now we will do question number 7. Now question number 7. If diagonals of a cyclic quadrilateral are diameters of the circle through the vertices of the quadrilateral, prove that it is a rectangle. Correct? It says if diagonals of a cyclic quadrilateral, means one quadrilateral ABCD is given which is cyclic. Cyclic means touching its 4 vertices are touching the circle. All the vertices means D is a vertex. This is the vertices. Vertices are touching this is quadrilateral, and its diagonals are the diameter. Diagonals are diameter means where it is cutting, it is the center. It is the center, and A to E is a radius, E to D is a radius. This full line is a diameter, means it is going through the center. So all diagonals AD and BC, diagonal AD and BC are diameters. So diameters means passing through the center and touching the vertices. Vertices means this is A and E is D are vertices, B and C is the vertices, through the vertices. So what you have to prove? You have to prove that ABCD is a rectangle. Okay. So here you see this is given. Okay, this is portion is given. Now solution. How the solution will come? You see, if you take the chord DCB, CDB, if you call this chord, so this chord is making one angle at point E. Okay. So here one angle it is making this chord, and one angle here it is making. Okay. So angle CEB is equal to 180 degree because it is a straight line angle. Okay. And angle CAB will be half of it. Why half of it? Because same arc CDB is making it. And as per the rule, the arc makes double of it at the center. Double angle at the center. So if it is double, it will be half. Half means 180, half it is 90 degree. So it is 90 degree. Now, this angle is 90 degree. BAC, CAB, you have proved 90 degree. Okay. Now, this angle and this angle, BDC, this all total should come 180 degree because it is given, it is a cyclic quadrilateral. So, sum of opposite angle in cyclic quadrilateral is always 180 degree. So, if CAB is 90 degree, so from 180 we will reduce it. Okay, so angle BDC will come how much? It will be 90 degree. Okay, so this angle is also 90 degree. This angle is also 90 degree. We have proved that this is 90 degree, and this also we have proved as a 90 degree. Okay, here we have proved it is a 90 degree angle. Okay, here in this way, if we take B and C also, this full angle B and C, we can prove in the same line, we can prove B and C also as a 90 degrees. It is the same procedure we have to write, and BC also we can prove. Now you see all the four angles, then you will become 90 degrees. So each angle of quadrilateral ABCD is equal to 90 degrees, means angle ABCD, all ABC here, you see A is 90 degrees. B is 90 degree, B is 90 degree, C is 90 degree. So all angles are 90 degrees. So ABC is a rectangle, and this is proved. Okay. Now we will cover question number 8. Hello, today next question we are going to cover is question number 8. Question number 8, what it says, if the non-parallel sides of a trapezium are equal, prove that it is cyclic. First thing, one trapezium. So given, what is given? A trapezium, A, B, C, D. It is a trapezium, and where parallel, non-parallel sides are this and this. So AC and BD are equal. Non-parallel sides are equal, and this is parallel side. AB and CD are parallel sides. Okay, this is given. Constructions we are going to make here to solve the question. We will draw perpendicular from A to A, perpendicular from A on CD line. From A, so AE perpendicular on CD we will draw, and from B we will draw a perpendicular on CD line, and BF, it will become BF perpendicular on CD. Now in this triangle and this triangle we will try to compare. So in triangle ACE and BDF, in this triangle and in this triangle, what is AC is equal to BD? It is given AC is equal to BD. This line and this line is equal, it is already given. Okay, this line and this line is equal, it is given. Angle AEC 90 degree, because perpendicular we have constructed, and BFD is equal to 90 degree because we perpendicular is drawn. So this is 90 degree, this is 90 degree, and AE and BF, this is the distance between parallel lines. AB is parallel to CD, AB is parallel to CD, so the distance from here to here will be equal. It means AE and BF will be equal. So triangle ACE will be congruent to triangle. This triangle will be congruent to this triangle BDF, and the criteria will be right angle, hypotenuse, and one side. Okay, so based on this, it is a congruent triangle, and if it is a congruent triangle, its ACE, A means this angle and this angle will be equal. Angle C will be equal to angle D, because CPCT. Okay, based on this corresponding part of congruent triangle. So this will be equal. It means angle C is equal to angle D. This we have proved. Now you see, AB and CD are parallel lines, and AC is a transversal line. So what will happen? This angle, this side and this side, these angles are co-interior angle, means it is inside a parallel line and in one side. So co-interior angle. Co-interior angles always equal to 180 degree. So BAC means this angle, and ACD means this angle, and ACD will be equal to 180 degree, because AB and CD are parallel lines, and this is co-interior angles. Now, as AB is parallel and AC is a transversal, so it is clear. Now, similarly, we can also, this we have proved. So similarly, we can also prove this upper side also. Angle B, ABD, angle ABD means this angle, and angle BDC, because if you take this side, now you forget this side, now if we will increase this side, okay, and this side, and this. So what will happen? Now it is a parallel line, and BD is a transversal line. So BD is a transversal line. It means this angle B and angle B will be what? Co-interior angle. So it will be co-interior angle, means angle B and D will equal to 180 degree. So we can prove also angle ABD is equal to angle BDC. So what we can say, we can also prove ABD means this angle, and this angle BDC will be 180 degree, because this angle and this angle are also co-interior angle. Okay. Now C and D are equal. So when we are showing A and C, angle A plus C equal to 180 degree, and C and D are also equal to, in place of C we can say A and D are also equal to 180 degree, because C and D are as C and D here as C and D are equal. C and D are equal. So what we can say, angle BAC plus angle BDC will also be equal to 180 degree. Is it clear? Because this angle BAC, this angle, and ACD, this angle, this and this are co-interior angle and equal to 180 degree. This angle is equal to this angle. So in place of C, we can also say BAC plus BDC are equal to 180 degree, C equal to D. Now you see opposite angles, if this opposite angles are equal to, opposite angles are supplementary means equal to 180 degree. So ABCD is a cyclic quadrilateral. In case of cyclic quadrilateral, all two opposite angles are equal to 180 degree. So this is your proof. Now question number 9 we are going to solve. Now question number 9. In question number 9, what it says, two circles intersect at point B and C. So one is this circle, one is this circle. They are intersecting at point B and point C. So two circles are intersecting at point B and point C, intersecting at point B and C through B. Through this B, two line segments A, B, D and PBQ are drawn to intersect the circle at point A, D, Q, P and Q. It is intersecting, it is cutting the circle. Okay. So what two circles intersect at point B and C through B, what happened? Two line segments ABD and PBQ intersect at circle here. So what constructions we have made? We have joined AP and DQ. Now we are coming to the solution part. So what we see, this line, AP is a chord. AP is a chord. So this chord is making one angle here. You see, this AP is making one angle here, and this AP is also. So what happened? ABP and this is also making. So it is a chord. AP is a chord. AP chord is making one angle at the circle. It is PBA. Yeah, ABP also we can say this angle B it is making. And the same chord, it is making an angle here also. PAC and P. And this angle and this angle will be equal because chords make equal angle at one side at the same segment. Okay. Similarly, here if you take DQ, if you take a DQ chord, DQ is a chord, so it is making one angle here, and DQ is also making an angle here also. Okay. So this angle DBQ and QCD will be equal because this is made by the chord in the same segment. Now, you see this line, ABD is a line and PBQ is also a line. So this is intersecting. They are intersecting at point B. So what will happen? Angle PB, angle DBQ, angle DB and Q. This angle, I will change the pen. So this angle, DBQ, because lines are crossing, so vertically angles are there. So this angle will be equal to this angle. This and this angle will be equal because they are vertically opposite angles. So what we can say, DBQ is equal to ABQ BP, ABP also we can say. Now you see, in place of DBQ we can write QCD also. So in place of DBQ we have used QCD so that we can reach up to the question QCD. So here we have proved DBQ is equal to QCD. Here we are writing, and ABP we have proved to equal to ACP. So here also ABP we are interchanging with ACP. Now we got the question answer. So ACP is this side and QCD we can write to this side, and we have reached up to the question and it is proved also. Okay. So in this way, now this question is over, this video is over. We will cover other questions 10, 11, etc. in the next video. Thanks for watching. Please subscribe our channel and share with your friends also. Thank you.